Okay, hi. We're going to talk now about global warming potential. Our learning objectives for this lecture are to first understand what is global warming and how does it affect us. And then we're going to try to understand how countries are trying to reduce global warming. And then we'll talk about carbon accounting methods and how they're used in order to try to reduce global warming. And then we'll discuss a carbon footprint and how you can calculate your own and think about what we can do to reduce global warming. So first, let's talk about what is global warming. Well, all the activities that we do, actually when we're burning fossil fuels, emit gases. And there are three types of gases that are emitted that are very important in global warming. They are carbon dioxide, CO2, and then the other ones are methane, so CH4, that's called methane. I'll write that in, methane. And then the other one is N2O. And these are the three main global warming gases, and they are emitted when we burn fossil fuels, for example. And so what happens is these gases act like insulators. So it's like putting a blanket over the earth. So if you could imagine all these gases, as their concentration increases because of some of the activities we do, what will happen is the radiation from the sun will come to the earth, and when it tries to leave, it will not go out. There's like a blanket that kind of keeps or retains the heat in, okay? And so the concept here is that these increasing concentrations of gases are insulating our Earth and keeping our Earth warmer. And these concentrations of gases are increasing because of activities that we do. So let's kind of take a look. This graph shows the temperature as a function of time. And what you see is that we are starting to get an elevation in the average temperature difference as time goes on. So basically you can see here that from 1980 to 2020, there's been a like plus 0.8 degrees Celsius increase in the temperature, average temperature. So what does that mean? When there are many different kinds of projections for temperatures, and it depends on what model you look at or predict, which will tell you where you think the global Earth temperature is going. There's different models. In the worst case scenario, we're looking at this upper red curve, and you can see that maybe it's a 4-degree increase in the global temperatures. That map on the right, on the top right, shows kind of what the temperature differences might be. There's spots that are at 8 degrees, and then there's spots that are lower. If we think about some actions to kind of decrease global warming, then maybe we'll come down to this blue curve right here, which would show a increase in average temperature, but a much smaller one. And that's based on activities that we are going to do to reduce the global temperature. As an example of how things are changing and the relationship between carbon dioxide and temperature, this graph is nice. It shows the carbon dioxide concentration in the atmosphere, and that has increased from about 290 to 380 over the last 100 or so years. And that can be correlated with the actual temperatures. So the blue lines are annual averages that are below this average temperature, and then the red are hotter than average years. And what you can see is that there's a very strong trend having hotter average annual temperatures, and that correlates very strongly with the carbon dioxide concentration in the atmosphere. So when we talk about global warming potential, really what we talked about was that those greenhouse gases, their concentration in the atmosphere is what insulates and warms up the Earth. Okay. Now, how do those concentrations change? And we'll focus mainly on carbon dioxide here. But it's true for all the greenhouse gases. We've got different pools of what we call carbon, and carbon is just kind of a shorthand for trying to kind of understand how much carbon dioxide is where, basically. And so in the geological pool, or in the Earth's soils and subsurfaces, we've got things like coal, oil, gas, fossil fuels that have stored there for a long time. They have a lot of carbon. And basically what happens with that is right now we're harvesting that coal and gas and oil, and we're burning it. And what that does is put a lot of carbon into the atmosphere. And so you can see the flows of carbon here. These are petagrams per year, very large amounts of carbon that are going in. So what happens is the carbon in the ground is burnt, carbon dioxide is released and other greenhouse gases, and then it goes into the atmosphere. And you can see we have an increase of 4.1 petagrams of carbon per year in the atmosphere, and that's what's doing the global warming. Now, there's another part to this. There's other pools. The biotic pool is where we have plants, okay? And the plants also interact with the atmosphere. And so when plants grow, every year we get about 120 petagrams per year of carbon taken out of the atmosphere and put in the plants. The plants actually do respiration, and that actually returns about 60 petagrams per year of carbon back. But the net of this is that more carbon dioxide is taken out. And what we can do is accumulate that carbon in plant material. There are other things that actually impact global warming. The ocean and how much carbon dioxide is in the ocean, and then also different soils that can decompose and actually cause carbon to go back and forth between the atmosphere. But really what we're trying to do in this course is understand how the biotic pool, if we use bioproducts and promote plant growth, how that can have a positive influence on the atmospheric CO2. All right, now when we talk about carbon emissions or greenhouse gas emissions, we can look at different countries. And these circles are very interesting. What happens is the cumulative greenhouse gas emissions for a country before 1960, they're actually in the small circle. So you can see in 1960, we had emitted a total carbon dioxide that's kind of proportional to that area. And then from 1960 to 2010, the increased area is trying to give us an idea about how much emissions we have added since 1960 to 2010 in a 50-year period. And you can see in the last 50 years, we've added just as much emissions as we had for all years up to 1960, excuse me. And so you can see that the United States is kind of growing in its emissions, not a positive thing. Let's compare that to the UK. If you look at the United Kingdom, you can see is that they had a global warming potential, greenhouse gas emissions, total emissions of this size circle. And what's interesting is that in the same time period, that has not grown as much as the United States. That indicates that they're trying to do different things to kind of slow down their greenhouse gas emissions. You can see Russia from 1960 to 2010 has really increased emissions. And here's really a very significant one. China, which has gone through a lot of industrialization and growth, has gone from a very small total amount of greenhouse gas emissions to a very large. This is a critical country in the overall global warming issue. One thing that this does show us, and I think it's very important, is this is the globe right here, and then this is the emissions up until 1960, and then these are the emissions from 60 to 2010. This globe is very important for us to see because it really tells us that even though we're individual countries, we're sharing. This is a global environmental issue that everybody is sharing in. Okay? You can see that the rest of the world has this behavior, and then there's some other countries. And what you see is that some countries are much better in curbing their global warming than other countries. Okay, so if we kind of look at who's doing what we're going to basically see is the top 10 countries, right? So all of the emissions are in this circle right here. And then the top 10 countries are producing about 75% of all the emissions. And you can see China, United States, the European European group of countries, India, Russia, Japan, Brazil. These all are contributing very large amounts of greenhouse gas emissions, whereas most of the other countries are small amounts. Okay? Just gives you an example. And then if you look for each country, you can see what is actually contributing. So the burning or the production of energy with burning of fossil fuels is big, other industrial emissions, and agriculture. And you can see similar thing, energy and agriculture for the United States, and same for Europe, India, Russia, and others. Okay, so why do we care about if the Earth is warming up? The global warming potential not only indicates that we're going to have higher temperature, but it's going to affect precipitation and sea level rise. So those are significant impacts. All of these things can have health, wildlife, health of the forests and coastal areas, and impacts on our agriculture. And then our water resources all can be impacted in a positive or negative way by global warming. Okay, so what are countries trying to do about it? Many countries have signed what's called the Paris Climate Agreement. That was in 2016. And the idea was that each country can contribute in some way to keeping global temperatures down. And then the goal is to, as you saw before, where there was an estimation of what's going to happen in the future, what the climate agreement says is we'd like to try to keep our temperature increases below 2 degrees Celsius. Okay, so a couple things about this. It's not a binding contract. So countries will enter this agreement as volunteers. So there's really no binding contract for that. 194 countries agreed, but some didn't. And it turns out that the ones that were not signed turn out to be just United States and Syria. All other countries are very involved. In the United States, we do care about global warming potential, and there has been a power plan that had standards set up, and the idea here was that the power plants would reduce a third of their greenhouse gas emissions, and that would have a lot of global warming savings and emissions. We're talking about 150 million cars. It's like taking 150 million cars off the roads. And hopefully the idea here is that some of these reductions in greenhouse gas emissions are going to cost some money, but overall society will benefit. In other words, what this power plan is suggesting will happen is that the savings in health costs and other benefits from better, plants growing well and things like that is going to outweigh the costs of that it takes to reduce those greenhouse gas emissions. And basically it's showing here that there's a multiplier of 7, that for every $1 that is invested, that $7 in health benefits will occur. Okay, so let's just talk about some of those countries and organizations that want to curb global warming. the fact of the matter is that society will pay you to reduce greenhouse gas emissions. So there are markets where people say, have you reduced some greenhouse gas emissions? If you have, I would like to pay you. Okay? What happens is if a company or industry or government, if they do a non-normal activity, so that what that means is normal activities would be just for the benefit of the company to increase profits. But if they do some activity that's not really not beneficial within profits, that would be considered a non-normal activity. So if they do a non-normal activity and it has that greenhouse gas reduction, someone may pay them. So one of the ways that we're trying to curb global warming is by incentivizing savings. So a cap and trade is a voluntary approach where companies or entities join in, and basically they are going to account for greenhouse gas emissions. So everybody will calculate their greenhouse gas emissions. The greenhouse gas emissions that they calculate and report usually are in what's called carbon dioxide equivalents. So even though you might have a methane or a N2O emission, they're all converted into what's called carbon dioxide. And oftentimes we just call carbon dioxide, we just call it carbon. And we just say, okay, a carbon credit is equal to 1 ton of carbon dioxide equivalent savings. And so what can happen is people will get carbon credits if they save carbon dioxide or decrease their global warming potential. And they can trade that. So basically, one company that might have a lot of greenhouse gas emissions might purchase from another company the savings that other company has in greenhouse gas emissions. So basically what's happening is everyone is agreeing that they will only emit a certain amount of greenhouse gases, and those that do emit more have to kind of pay those that save more, so that the net is not an increase in greenhouse gas emissions. This can occur on a company or country level. Now, the other way to try to curb global warming is to penalize. So a carbon tax is a penalty. So a country or state or entity might put a penalty on greenhouse gas emissions. So what that means is people will track how much greenhouse gas emissions they have, or organizations, and then they will be a tax. So for every ton of carbon that you emit, you'll have to pay a tax to the government. And hopefully that government will use that tax for other types of carbon savings, programs to kind of save carbon. These kind of carbon accounting methods are in effect in 40 countries currently. So if you ask yourself, well, what is the value of carbon savings? I said before that people will pay you to save some carbon. Carbon savings has a different price in different areas, and it changes with time. It's like the price of a stock. And basically what you can see here are countries and organizations and states that are involved in putting down a price for carbon and saving it. What you'll notice is that the United States, for the most part, is not involved except for California, but Europe and Asia, Canada, and some other countries are. The size of these bubbles actually tell you how much carbon emissions that are kind of regulated by that price. So you can see that the market in Asia is the biggest, and then in Europe it's smaller, and then you've got smaller ones in the United States at this point right here. That means that they're kind of controlled or helped by these carbon accounting practices. Okay, so let's just take all this down to an individual. What you hear a lot about is a carbon footprint. The carbon footprint is basically the total greenhouse gas emissions of a product or activity or entity. Okay, so so a company could have a carbon footprint, a country could have one, or just an individual person. So basically, there's a lot of different carbon footprint calculators. Okay, and they're on the internet and they're available. So you know that what they will do is they will say, okay, in your activities as you live, things like using electricity or driving a car or traveling on an airplane, all those activities, they'll use those as inputs, and they will calculate the average greenhouse gas emissions of some of those activities and then calculate your carbon footprint. So at this point, yeah, I'd like you to go ahead and try to calculate your carbon footprint. And the carbon footprint calculator that we'll use is right here. Okay? And so go ahead, go to that, and then try to calculate your carbon footprint. Okay, now we're back, and hopefully you were able to calculate your carbon footprint. And I just want to show you my personal carbon footprint, how it breaks down. So this carbon footprint is for a year. So the total carbon footprint that I personally have is about 25 metric tons of carbon dioxide equivalent per year. And if you take a look at how that breaks down, part of it is my house. So the most significant part of my house is electricity. We use electricity for lights, and we also use it for cooking and for heating the house. So we get 2 metric tons of carbon dioxide. So there's one part of it. I take about 6 or 7 flights a year, some overseas and some domestic, and that actually has a very high greenhouse gas emission or carbon footprint contribution of 3.5. Then car is another one. I drive my car about 10 to 12,000 miles a year. I have a pretty fuel efficient Honda Civic, and that contributes about 3.8 metric tons of carbon dioxide per year. And then you can see that the other category is what's called secondary processes. And those would include things like, what is the food I eat? What are the clothes that I buy and wear? What are some of the entertainment activities that I do? Just almost all, it's a kind of a catch-all for all the other activities that I participate. And you can see that those are very large, okay? So it turns out that we can identify some obvious things like houses, flights, and cars, but that's not the entire story. A lot of the carbon footprint that at least I'm involved with is kind of dispersed amongst a lot of small little activities, which makes it more difficult to save. But there's still possibilities. I think doing a carbon footprint, a personal carbon footprint like this, kind of helps you be aware of what activities contribute to this, and maybe some of the ones that might have good potential for improvement. Now, here on the right also tells you a little bit of a story. My carbon footprint of 25 metric tons of CO2 equivalent per year, if you kind of look at it as an area of a foot, it would be like this. And then the United States country average is about half of that. So it looks like I'm a bad offender. And then if you compare our United States country average with the world target, you can see that the world target may be 1/10 or so of that. And so basically the point here is that the way that we live in the United States is such that we have a good quality of life and things, but it comes at a price, and it's carbon emissions. So another thing you can do with some of these calculators is calculate how you might save in global warming potential or carbon emissions. And so there's usually ways that they describe or suggest that you can improve. Next thing I'd like to talk about is where are we going with carbon dioxide concentrations in the atmosphere? This graph right here shows global CO2 emissions from 1980 up until about present. And what you see is our present trajectory is increasing, where carbon dioxide concentrations are actually increasing. And if we don't do anything, they're just going to keep increasing, and then we'll get that global warming that we don't want. But how can we go ahead and try to prevent global warming greater than 2 degrees Celsius? Well, there's different technologies, and what those technologies should do is they'll actually take carbon dioxide out of the atmosphere. So there'd be what we would consider negative emissions. And what that is hoped to do is to reduce our net emissions from this high level down to a lower level or even zero. So what are these kinds of technologies? Well, all these technologies, what they try to do is just take carbon dioxide out of the atmosphere and not put it back in. So one way that we can do that is by soil sequestration and forest management. So when we grow a new forest, what happens is there's a lot of carbon that's stored in that tree, and it can be stored in there for many, many years. And also, if we leave the soil undisturbed, the soil can accumulate a lot of that carbon. So that's a very useful way, of storing carbon in forests. Wonderful idea, right? Another way that you could do it, a little bit more costly and a little bit more complicated, is to store the carbon in the soil. But this time what we would do is we would take trees that have grown. So the trees have grown and they've taken CO2 out of the atmosphere. And instead of combusting them, what we would do is we would convert them into a char. Okay, so a char basically is a dense carbon. It's like a charcoal briquette. So what we would do is we'd make charcoal briquettes in a simple form, and then we'd take those charcoal briquettes that have all that carbon, and we'd just bury it in the ground, and it would be stored there and stay there for a very long time. Then the last one would be actually using bioenergy and capturing some of the emissions and storing them. So what does that mean? That would mean that we would grow a tree, which would take carbon dioxide out, and then we'd burn that tree for energy that we need. So that's going to happen anyway. But from the smokestack, what we would do is we would divert that carbon dioxide from going to the atmosphere. And we would use some technologies to kind of capture that CO2 and again, store it away from the environment for a very long time. So what you can see is that 2 and 3 are pretty complex technologies that are going to cost some money. They're not normal activities, but they may be activities that we need in order to reduce our global warming. And then number 1 is just, I think, a nice thing to do. Encourage forest growth and natural soils that are undisturbed, and that should help our environment. And it also fits right nicely into the bioproducts and bioeconomy. This graph just kind of shows you some of the ways that we can sequester the carbon dioxide, take it out of the atmosphere and not go back in. So basically what we can do, the first one right here is on the upper left is what we were talking about, where we grow plants, which take CO2 out of the atmosphere, and then when we burn it, we actually sequester that carbon dioxide. So in this diagram right here, this arrow is showing instead of the smokestack, all the CO2 is pumped underneath the ground and just stored there for a very long time. The plus is the greenhouse gases don't go to the environment. The minus is we're putting a lot of gas in the ground, changing the environment. Forestation we talked about, that's a wonderful idea, where the forest, the trees that are grown in the forest, and a lot of the soil that is undisturbed gathers and collects carbon and just stays there. That's good. There are other technologies where we just take the carbon dioxide out of the air. We might absorb them into solids and things and then just store them like that. Biochar is the other one. We talk about the plants that are grown. They take the CO2 out of the environment, and then we heat them up with not a lot of oxygen. That makes the charcoal that we were talking about, the char, and then the char can be buried in the ground and it doesn't release into the atmosphere. And then there are other methods too that are pretty exotic. Ocean fertilization is another example where we're trying to get plant materials in the water to consume carbon dioxide, but you can imagine how expensive, complex, and with what kind of uncertainty there is in doing a technology like that. Okay, so let me just kind of summarize what we've done. First thing we did was we talked about global warming, the insulation of the earth from these greenhouse gases in our atmosphere. Then what we did was we reviewed some potential impacts of these global warming, like sea level change, things like that. Then we provided some ways that you can take carbon dioxide and other greenhouse gases out of the atmosphere and sequester them in order to try to combat global warming. And then we talked about the 2 different ways that we have to try to reduce global warming. One is a cap and trade, where people that save carbon dioxide can be paid by other people. And then the other one is a carbon tax, where if you emit greenhouse gas emissions, you have to pay a government, and that should incentivize you with a penalty not to partake in that activities. And then finally, we talked about how to calculate your own carbon footprint. And that's the end of my talk. Thank you for your attention.